Okay, so we are going to look at solving systems of equations by graphing. We are going to look at number 5 and number 6 from the homework. First, let's look at number 5. And so if you get confused on any of this, you can rewind it, rewatch it, rewind it, rewatch it until you finally understand. Or you can look at the Khan Academy tutor links. So here we go. We're going to graph the first line, y equals 3x minus 4. We start with the y-intercept, and then we know our slope is 3. That as a fraction is 3 over 1. So we're going to rise 3, run 1. 2, 3, 1. 1, 2, 3, 1, 2, 3, 1. We then connect our dots with a line. And so now we're going to do this equation. Y-intercept is 3. Our slope is 1 over 2 in the negative direction. So up 1 over 2, or down 1 over 2. This is going to be in the negative direction. And what we get when we connect those dots is that these lines cross right here. That is the point 2, 2. So x equals 2 and y equals 2. So where these two lines cross, that is the solution to the system of equations. You could plug 2 in for x here and 2 in for y here, and it would make this equation true and this equation true. So let's do the exact same thing. So let's do the exact same thing over here on this one. This line, we're going to start at positive 2, because that's the y-intercept. We're going to go 2 over 1 in the negative direction. Up 2 over 1 in the negative direction. And like before, connect that line. And then we're going to go to this line, negative 2, and it's also up 2 over 1 in the negative direction. And so when we graph that line, we get something like this. Now notice that these lines never cross, so no solution. And this is because they are parallel lines. Remember, parallel lines are lines that never cross. And we know this because they both have the same slope. So we really didn't even have to do all this work and all this graphing. We could have just seen that because the slope is the same, negative 2, negative 2, we know that there can't be any solution to the system of equations. All right, so that is solving by graphing. Now, I'm going to stay on the solving by graphing page, or I'm going to come back to it rather in a little bit to show you an example of substitution. But the next thing we're going to do, because it's probably the most confusing, is talk about substitution. So you need to get out your substitution, that's elimination, substitution worksheet. And I am going to look at number 2 and number 4. So substitution seems hard, but it's not so bad. Because y equals x minus 1, that means wherever we see a y in the other equation, we can change it to x minus 1. So if I do that, it'll look like this. See, all I did was take this x minus 1 and put it in for that y. So this parentheses, this x minus 1 here, took place of that y. And that's what substitution is. And so now we're just going to go about this like we would any other problem involving one variable. We're going to distribute. And so when we distribute, that becomes and so how did we get this? Well, negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. So that's how the distribution works out. Now we notice that these are like terms. They both have an x. And so we are allowed to combine those together. 2x minus 3x will give me negative x. And so I'm going to go ahead and do that, combine these two together. And now my equation looks like this. Negative x plus 3 equals negative 1. Now we're just going to solve the equation for x like we would any other problem. We got to get the x by itself, so we need to subtract 3 from each side. 3 minus 3 is 0. What we do to one side, we have to do to the other. Now here's where you got to be careful. Don't be afraid to check with your calculator. Negative 1 minus 3 is going to be negative 4. Negative 1 minus 3 is negative 4. It's the same thing as saying negative 1 plus negative 3. And so that would make it become negative x equals negative 4. Almost done. To get this x finally by itself, we are going to have to divide each side by negative 1.
Sophie Baker, please come to the West Mall office.
And so negative 4 divided by negative 1 is going to give me that x equals 4. And now we're going to apply the same logic that we did here to find x equals 4, and we're going to substitute that in for x somewhere up here to solve for y. So let's check this out. If x equals 4, then that means anywhere I see an x, I can change it to 4. So I'm just going to change that x right there to 4. So that equation would now become y equals 4 minus 1. That is simple enough. 4 minus 1 is simply 3. So x equals 4 and y equals 3. Now if we would have reorganized these to get two slope-intercept equations and graphed them, they would cross, the two lines would cross at the point 4, 3. So you can write the solutions to these equations as an ordered pair, where x comes first, so it is 4, y comes second, so it is 3. Now, if that confuses you and you need to go back and take a look at it, rewind this and take a look at how I did it again. I am going to do, and actually I'm going to come do number 1 instead. That way I don't have to scroll down and I can leave all this work over here. So let's look at number 1 now. Same exact concept as before. Now, it's a good idea to use substitution when there's a variable by itself. Y is by itself, so we can substitute. So because y equals 6x minus 11, I can plug that in for that y there. And so when I do that, see if you can pause the video and write what equation you think will result by substituting 6x minus 11 in for this y. When you're ready, hit play and see if you are right. I'm going to go ahead and continue on. And so what I've done is I've changed this y right here to 6x minus 11 because it means the same thing. If y equals 6x minus 11, y is 6x minus 11, I can just change that y to 6x minus 11. It's no different. And so now it just becomes a matter of doing the math that we've been doing since day one. We distribute. Our distribution leaves us with this equation. Negative 2x minus 18x plus 33 equals negative 7. Again, negative 3 times 6x is negative 18x. Negative 3 times negative 11 is positive 33. Once again, these are like terms. We can combine them. That's no different than saying negative 2 minus 18. We could just combine them that easily because they're like terms on the same side of the equal sign. And so we're just going to do that. Again, negative 2 minus 18 is going to give me negative 20x plus 33 equals negative 7. Excuse me. And now we just solve for x. Minus 33 negative 20x equals what you do to one side, you have to make sure you do to the other. Negative 7 minus 33. Again, there's that negative. So you can make it negative 7 plus negative 33, or just do negative 7 minus 33. Either way, you're going to get negative 40. And then so when you divide each side by negative 20, negative 40 divided by negative 20 is going to give me positive 2. So x equals positive 2. And so now again, because x equals 2, anywhere I see an x, I can change it to 2. So I'm going to go ahead and do that. Again, see if you can pause it and write the equation by yourself before I do it. And so y equals 6 times 2 minus 11. I just replaced that x with 2. So now y equals 6 times 2 is 12. And that becomes real easy. Y must equal 1. And so again, when you have your x and your y, you can write that as an ordered pair. And so 2, 1 would be the solution. Again, if I rearranged these and graphed both of these lines, I would get 2, 1. Now, if substitution isn't your thing, and you never want to substitute, I understand. You could eliminate this. You could minus 6x over here and set it up to where it's negative 6x plus y equals negative 11, and negative 2x minus 3y equals negative 7. And you could do elimination, and that would work just fine. Or you could solve for this y, add 2x to each side, and then divide everything by negative 3, and graph both lines. And they would cross at the point 2, 1. You could do that. I just am interested in you getting this answer right here. That's really the most important. Now, a lot of you have complained or expressed concern about how difficult substitution is, and I agree, it's not the most appealing thing to use. I mean, this is a lot of work going on. But let me show you a situation where I think it actually works out to our advantage. So let's go back to the graphing worksheet That's this first one here. And I want to go all the way to number 2. This one right here. Now, we could plot these lines and graph them, and they would intersect at a point, and it would tell us the right answer, and everything would be okay. But let's say we're doing like a bookwork assignment, and so you don't have a graph. It's not there. It's not available. And so instead of taking the time and drawing a graph and writing all the dashes, and maybe you're just not good at writing the equation of a line, and that intimidates you, and so you would like to know a different way to do it. This is the other circumstance where it's a really good idea to do substitution. Because if you look, y equals 4x plus 3. So that means I can change my y in any other equation to 4x plus 3. And so when we do this, we actually don't have to distribute, we don't have to do anything like that. It actually is going to paint a pretty nice picture for us. We will get 4x plus 3 because I replaced this y with that substitution equals negative x minus 2. And so that's nice because now we have everything in terms of one variable. We don't have to distribute. It's just simply solving an equation. We are going to add x to both sides. And when we do that, we get 5x plus 3 equals negative 2. Because that minus 2 is still left over there. And then so, oops, I forgot my x. And then we are going to subtract 3 to get our x by itself. And hopefully you can kind of see what's happening here. 5x equals negative 5. And the last step, of course, divide each side by 5. X equals negative 1. And then now, since we know that x equals negative 1, we can plug that in and solve for y. And so when I do that, I get something really nice. Y equals negative x minus 2. Well, negative 1 becomes positive 1. And 1 minus 2 equals negative 1. And so if we were graph this, we would assume that these lines would cross at the point negative 1, negative 1. And so just to kind of prove to you that you could do substitution in this case, I'm going to go ahead and graph these really quickly. I'm just going to move these lines over here for now because I might need them. So the first line I'll do in red. It starts at 3 and it goes up 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And so I'm just going to use this arrow to connect them. Whoops, that's not what I wanted. And then I'll use green for the other one. It crosses at negative 2, and it goes up 1 over 1 in the negative direction. And you can already see that these two lines will cross at the point negative 1, negative 1. So x equals negative 1, y equals negative 1. So if you don't like substituting on the other page, that's fine, but this is a pretty good scenario to use substitution. And you know, if you don't like to graph, because there are some times where your lines might cross in between numbers, and then so you're going to have to make an educated guess. And you know, maybe you'll guess correctly, maybe you won't. Substitution, you will be able to get decimals and fractions and things in your answer. Whereas graphing, if they don't cross at a nice pretty point like this, then you might not have as correct as an answer as you might have wanted. All right, and so the last thing I'm going to do is show you 2 elimination problems. And that'll be it. And so if you have any questions that you specifically want to see, you can go ahead, send me an email or something. We are going to look at number 8. Well, let's see. I want to try to look at some that are on the same page. So I should be able to do 8 and 11. Those were the 2 that I wanted to do. So let's try to do 8 and 11. Now, maybe we need to do one that's not in order first. They all look like they're in order. Here we go. So actually what we'll end up doing is we'll do 22 and 23 because 23 is very important. So I'm going to write up here the first rule of elimination. It has to be in standard form. And remember that's AX plus BY equals C. And you need both of your equations to do that. So it needs to look like this on both fronts. Your x's over your x's, your y's over your y's, and your numbers over your numbers. And so if we look here, x over x, y over y, number over number. This is good to go. We can go ahead and get started. And so that was the first rule, has to be in standard form. The second rule is that you need one of your variables to have the same number. Now I actually did this example in class for 4th block right before they went to their freshman registration, but I'll show it again because that's okay. This can be done a couple of different ways. And so in fact, I'm going to do 21 instead, since I've already really done this one. So the second thing is you need your variables. Pick one variable that has same coefficient. What that means is the number in front of the variable needs to be the same. See how that's 5 and that's 3, that's 4 and that's 6. So we've got to make these the same somehow. And so how you can do that if they're not the same is you're going to have to multiply one or both equations by a number to make this happen. And you could technically do division. You could divide one or both equations to give them the same number, but more often than not, it's going to involve multiplication. So we can do either one. We can try to make our x's the same or try to make our y's the same. And so if I wanted to make my y's the same, I would times the top or multiply the top by 6 and the bottom by 4. That would make both of these 24. I could also do the top by 3 and the bottom by 2 to make these both 12. Either one would work. It really doesn't matter. I could make the x's the same by multiplying everything on the top by 3 and everything on the bottom by 5. That would make both of my x's 15. That would make both of my x's 15. So what I'm going to do is probably the path of easiest resistance, the smallest numbers possible, and I'm going to multiply everything on the top by 3 and everything on the bottom by 2. And so when I do this, I'll get new equations. Come on. I will get 5 times 3 is 15x plus 4 times 3 is 12y equals negative 14 times 3. If you have your calculator handy, that's an easier way to do it. Negative 14 times 3 is negative 42. Then on the next line, 2 times 3 is 6x plus 6 times 2 is 12y equals 6 times 2 is 12. So now x is over x's, y is over y's, numbers over numbers, and the y coefficients are both 12. And so that's what we wanted. So now how do I make two positive 12s go away? Well, if I added 12 plus 12, that would give me 24. So I don't want to do that. So I want to make sure I subtract. And I'm going to subtract everything. And so when we do this, 15 minus 6 gives me 9x. 12 minus 12 is 0y, so my y's effectively have canceled out, equals, now you got to be careful here, negative 42 minus 12 is going to give me a bigger negative number, negative 54. It'd be the same thing as saying negative 42 plus negative 12. So I get negative 54. Now all I have to do is solve for x, since the y's have canceled out. So I divide each side by 9. And negative 54 divided by 9 is going to be a negative 6. And so my answer for x is x equals negative 6. And so now that I know, see, if you didn't like substitution, you're going to have to do it somewhat. Because now that I know that x equals negative 6, I have to plug it back into an equation. And so when I do that, oops, it'll look like this. 5 times my x plus 4y equals negative 14. And so then I just go through and do all the math. 5 times negative 6 is negative 30 plus 4y equals negative 14. If I subtract 30, or I'm sorry, you do the opposite, add 30 to each side. Negative 14 plus 30 gives me 16. How convenient is that? And so over here, I'm just going to kind of go up here. 4y equals 16. Obviously now we divide both sides by 4 to get y by itself. Brings us down finally to y equals 4. And so with x equaling negative 6 and y equaling negative 4, I'm sorry, y equaling 4, our answer would look like that. So that is elimination. It's probably one of the more efficient ways to do it, as long as you remember these rules here. Has to be in standard form, make one variable have the same coefficient. You do that by multiplying one or both equations by a number. And then you just go through and you solve the equation. I need to quit scrolling. Okay, so now this one right here, we have a problem. X's aren't over X's, Y's aren't over Y's, numbers aren't over numbers. Now, we can rearrange this first one because it's basically X, Y, and 14. So I'm just going to rearrange that one. Negative 7x minus 20y equals negative 14. See how I did that? Negative 20y minus 7x is no different than negative 7x minus 20y. It's the same thing. Negative 20y plus negative 7x. You could rewrite that as negative 7x plus negative 20y. Y have a plus negative together. You can just rewrite it like this. Now this one, so I'm going to put it kind of down here a little bit. Now this one, oops, has some issues. Y plus 4 equals 2x. We've got to get the 4 over here and the x over here. So first, I'm going to subtract my 2x from each side so I can get my x where it needs to be. And so now this equation becomes negative 2x plus 10y plus 4 equals 0. We're still not where we need to be because I need the 4 over there. So I need to subtract 4 from each side. And once I do that, then I'm finally where I need to be negative 2x plus 10y equals negative 4. So now I've got two equations. The x's are over x's, the y's are over y's, and the numbers are over numbers. And then it becomes very obvious. So step 1, done. None of my variables have the same number. 2 and 7 aren't the same, 10 and 20 aren't the same. So what I need to do, one that becomes very obvious, is if I multiply the top line by 2, then my y's will be the same. So I'm just going to go ahead and do that. We're going to times everything on top by 2. And so when we do that, we get 2 times negative 2 is negative 4x plus 20y equals negative 4 times 2 is negative 8. And so now we have x's over x's, y's over y's, numbers over numbers. Now here's where you got to be careful. To get negative 20 and 20 to cancel out, I would add them. Because if you do me a favor, if you type negative 20 minus 20 in your calculator, you'll get negative 40. That's not our goal. But if you do negative 20 plus 20, you'll see that that gives you 0. And that is the goal. So negative 7 plus negative 4 is going to give us negative 11x. Whoops. And then the negative 20 plus 20 cancels out my y's because it makes 0. And then negative 14 plus negative 8 gives me negative 22. And so now all I have to do is divide each side by negative 11. And that gives me a nice number, x equals 2. And then once again, if you don't like substitution, you're going to have to do it a little bit. If x equals 2, I've got to solve for x. I'm solve for y by plugging 2 in for x. So how would that look? 10y plus 4 equals 2 times x, which was 2. That becomes 10y plus 4 equals 4. If I subtract 4 from each side, that gives me 10y equals 0. Dividing by 10, 0 divided by 10 gives me y equals 0. And so because x equals 2 and y equals 0, I can make an ordered pair for the answer of this to be 2, 0. So I hope this has been beneficial. I've done a couple examples of each. Tomorrow we're going to take what we've learned here and try to write story problems out of them and then solve story problems based on these systems of equations. If you have any specific questions, shoot me a Canvas message. I'll try to walk you through it as best as I can. Just remember to eliminate standard form, x's over x's, y's over y's, numbers over numbers. Variable have the same coefficient, and then get rid of it, substitute at the end. Substitution, you only have to do 10 total problems, 5 evens, 5 odds from the worksheet. So hopefully you'll be able to struggle through that. We can go over those tomorrow if you need to. And then the graphing one, you should be able to do. You just have to make sure they're all in slope-intercept form, which is the y equals mx plus b. I hope you guys find this helpful. Let me know if you have any questions.